Now we're going to talk about giant covalent structures. Now, we have three giant covalent structures which are diamond, graphite, and fullerene. So, now diamonds and graphites are allotropes of carbons which have giant covalent structures. Now, this class of substance contains a lot of non-metal atoms because carbon is a non-metal, each joined to adjacent atoms by covalent bonds, forming a giant lattice structure. So, the carbon atoms are chemically combined together by covalent bonds. So the giant covalent structures have high melting and boiling points as they have many strong covalent bonds that need to be broken down. So some of the properties of diamond are each carbon atom is bonded with four other carbons forming a tetrahedron. So all the covalent bonds are identical and strong with no weak intermolecular forces. So because of this, diamond does not conduct electricity but has a very high melting point and is extremely hard and dense. So diamond is used in jewelry and as cutting tools. Now, some of the properties of graphite are that each atom is bonded to three others, forming layers of hexagonal shaped forms, leaving one free electron per carbon atom. This means that graphite can conduct electricity. Now, the covalent bonds within the layers are very strong, but the layers are connected to each other by weak intermolecular forces. So that means that the layers can slide over each other. This makes graphite slippery and smooth. Also, graphite has a very high melting point.